So my point here is to explain this Coriolis effect, yeah, yeah, what's called Coriolis force, because my question happened to be wrong in that portion also. So I will try to explain it. Maybe I might be wrong in the conceptual, in the conceptual portion. So I have gone through it, but little bit I can explain it. So what do we mean? Like, what's winds? Winds is air in motion is called a winds, or we can say wind always flow from like high pressure to low pressure. This thing is in golden line because for solving the problems, winds always move from high pressure to low pressure. Whenever there is a pressure difference, or it's called pressure gradient, it causes wind to move from high pressure to a low pressure. This red line you have to remember it because there is no alternative to this. Factors affecting the wind motion. When there is a movement of wind, or the wind is simply, we can say, a movement of air from high pressure to the low pressure, there is a wind. What are the factors that affecting the motion of wind? First is the pressure gradient force. What do you mean pressure gradient force? Simply in the earth's atmosphere we have the pressure, in different layers there's a different pressure. So there are pressure bars in the in the earth's atmosphere. The rate of change of pressure with respect to the distance is called the pressure gradient. In lower atmosphere there may be lower pressure. When you go to the higher levels of the atmosphere, you can say there's a low pressure. There when there's a like difference in the pressure from high pressure to the low pressure, there's called pressure gradient, or there's a pressure difference, or which we call a pressure gradient. Sim- Similarly, pressure differential in the atmosphere cause the movement of air from high pressure to the low pressure. That we know that pressure gradient force is more when isobars are closely placed. It means that in the Earth's atmosphere, if there's a little distance between the one isobar and the next isobar, it means that there's a very high variation of very high variation of pressure in a very little distance between the isobars. Simple way you can say that. If there's a very large distance, means there is a very less variation of pressure from one isobar to the next isobar. Simply, simply frictional force. These are also affecting the winds. I- We know that when we move on the earth's surface, or anything when it moves on the earth's surface, it experiences some friction. Similarly, winds are also experiencing the friction. Any moving object near to the land surface experience frictional force. Similarly, we as a humans are experiencing some frictional forces when we try to run. Some winds are opposing our motion to run. Simple way. Similar winds are also experiencing the frictional forces. Frictional force is maximum along when the land, okay, it's maximum near the earth's surface or a higher altitudes. The winds are high speed or altitudes rather than the lower altitude because of high frictional force. As we know that in earth's surface there is a greater wind speed. Like simple way you can say that in the earth's surface there is a greater wind speed compared to the higher altitudes. Now coming to this Coriolis force. What do we mean by Coriolis force? It's not exactly a Coriolis, but it's a pseudo force. Like in conceptually, in practically, we experience the Coriolis effect. From that Coriolis effect, we give the name it to the Coriolis force, but it's not a pseudo force. It's simply a pseudo force. But practically, here we can experience the Coriolis effect. Coriolis effect I can explain little bit. There's not much concepts here. Say for example, we have a body A and we have a body B. Okay, this body, like both these have the same angular velocity. It's called omega. They have the same angular velocity, but the linear velocity along the horizontal portion, they have the different linear velocity. The like anybody in at the point A having the more linear velocity because they have to, he or she has to cover a very large distance compared to the anybody in the at B, because he or she has to cover very less distance to cover to cover like he has to cover this much distance. This boy has to cover that much amount of distance. So definitely A has a very high linear distance compared to that of B. After that, we are utilizing the negotiating effect, simply the effect. Similar way, if A is here, his linear velocity is along this side, and simply he's moving along this side. Neutral effect के हिसाब से that he like there, there will be a balancing effect. It will move along this direction. You have solved these problems along the reverse stream problem. Simple concept is involved here also. Similarly, in that way we can say the winds are moving in in northern atmosphere. Winds are moving along the right direction. Similarly, in the southern direction, southern hemisphere, winds are moving along the left direction. This much you have to know. Simple way, like remember it. Winds in the northern sphere are moving in the right direction. Winds um, in the southern hemisphere are moving in the left direction. That's more than enough. We have to remember. And Coriolis force is maximum at the poles and least at the equator. You have to understand it. The Earth's rotation on its axis from west to east direction is responsible for the Coriolis force. Coriolis force, because Earth's rotation from west to east direction along its axis is responsible. That this is Earth's rotation is responsible for the Coriolis force. The degree of Coriolis force depend upon speed of a moving body, latitude at which the motion body is in motion, the speed of the rotation of the Earth. After that, we have the gravitational force that you can know. After that, we have geostrophic vents or geostrophic vents. What do you mean geostrophic vents? Geostrophic vents simply means that when the pressure gradient force neutralizes or equalizes the what Coriolis forces. In that portion, we have the winds that are running parallel to the isobars. Simple way here is explaining that always in the Coriolis forces are always perpendicular to the isobars, like what's called pressure gradient force. At some altitude, when isobars are straight, there is no friction. Pressure gradient force is balanced by the Coriolis forces, and the resultant wind move parallel to the direction of isobars is called the geostrophic. Simple way you can say that when the winds are parallel to the isobar, these are called the geostrophic winds because the pressure gradient force is balanced by Coriolis force. Normal winds move from high pressure to low pressure, with that you have already known. Now the question come from this graph, this table. We know that in the in the northern hemisphere, winds move from high like usually the winds or the Coriolis effect, Coriolis force move along the northern northern direction. In the southern hemisphere, winds move from along the left direction or the left direction. Simple way that, say for example, cyclone, if we experience, say for example, in the northern hemisphere, साइक्लोन में क्या होता है, जो इनर पोर्शन होता है, इनर पोर्शन वहाँ पे लो लो क्या बोलते लो पर प्रेशर होता है, और जो आउटर रिंग होती है वहाँ पे हाई प्रेशर होता है. As we know, in the northern portion, wind move from wind move along the right direction. If we go to the outer ring to the inner ring, to the low pressure, from this one high to the low, we have to move along a right direction. In this way it will go, and it will go this way, it will move along the right. It's a cyclonic movement. Precondition: cyclone pressure condition at the center is low. सॉरी, साइक्लोन में क्या होता है, सिंपल साइक्लोन में क्या होता है, जो इनर पोर्शन होता है उसका, जो इनर पोर्शन साइक्लोन का, वहाँ पे प्रेशर लो होता है. साइक्लोन व्हाट यू कैन से हियर इज साइक्लोन. साइक्लोन में इनर 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 जो पोर्शन होता है वो लो होता है, ठीक है. वहाँ पे लो लो प्रेशर होता है कंपेयर टू द आउटर. मतलब जो यहाँ पे जो साइक्लोन होता है, इसमें जो इनर पोर्शन है वहाँ पे लो प्रेशर होता है, जो आउटर रिंग जो होती है वहाँ पे हाई प्रेशर होता है. If we can see it in northern hemisphere, नॉर्दर्न हेमिस्फीयर में क्या, what we know that in the northern hemisphere winds move from high pressure to the low pressure along the right direction. If we go along this from from high pressure to low pressure, it will go along this anti-clockwise direction. Clockwise direction क्या होता है, which run in a similar way along the clock move this way in this clockwise direction. This is anti-clockwise direction. So cyclone, that is, which has a low pressure at the center, in the northern hemisphere it will move along anti-clockwise direction. This is northern hemisphere. Similarly way, if we in the what southern hemisphere, what we know that winds move from high pressure to low pressure along left side. So this from high pressure to low pressure, it will go along this way, so it will be along clockwise. Similarly, anticyclone क्या होता है, anticyclone simple, which has a high pressure inside and low pressure outside. सिम साइक्लोन में क्या होता है, लो प्रेशर एट द इनसाइड बट हाई प्रेशर द आउटसाइड. एंटी साइक्लोन में क्या होता है, हाई प्रेशर इनसाइड, लो प्रेशर outside. If we see it in northern hemisphere, what we know that winds move from high pressure to low pressure along the right direction. High to low, if we move along, is in cyclonic direction. Like this is called clockwise direction. Like anticyclone in the northern hemisphere will go in clockwise direction. We use in clockwise in simple way. This is going the clockwise direction. But if we go in the southern hemisphere, winds move from high pressure to low pressure in the left direction. It will go along this way, so it will be in anti-clockwise direction. So maximum question are coming from this graph. So okay, after that we have the planetary winds. What do you mean planetary winds? Winds that are in the upper Earth's atmosphere. These are called simple planetary winds. These are the planetary winds. ज़्यादा कुछ we don't have to go too much, but this picture is very important to understand the planetary winds. This is the equator. Zero at the zero degree, 30 degree. After that we have 60 degree. We have 90 degree. At 0 degree we have this called equatorial low. This you have to remember, equatorial low. And the 30 degree we have the subtropical high, or is called Horus latitudes. We have the 60 degree, it's called temperate low. And we have the 90 degree, at the 90 close to 90 degree we have polar high. Similarly, in the southern hemisphere, we have the subtropical high, which is called Horus latitudes. We have the 60 at the 60 degree, we have the temperate low, and we have the polar high at the 90 degree. What do we mean by trade winds? ट्रेड विंड्स या उनको हम कहते हैं नॉर्थ ईस्ट विंड्स और साउथ ईस्ट ट्रेड विंड्स. ट्रेड विंड्स और नॉर्थ ईस्ट ट्रेड विंड्स और साउथ ईस्ट ट्रेड विंड्स. What are north east trade winds or south east trade winds? Those winds which winds we know that are flow from high pressure to the low pressure, low low pressure. At the equatorial, usually we know that there is what, low pressure. There is a low pressure. Yes, because in at the equator there is a high concentration of the sunlight, which results in higher evaporation. When there is a greater evaporation, at the surface of Earth there is a low pressure, but at the upper layers of the like at the top there is a low pressure. Simply at the equator, at the Earth's surface, close to Earth's surface, there is a low pressure because of high evaporation. When you go to the little upper atmosphere, there is a high pressure because the vapors are accumulating at the upper atmosphere. Simple. A simple concept. We know that winds are flowing from high pressure to the low pressure. So it means that from upper atmosphere, winds are coming towards the Earth's surface. Earth's surface. So which gives this one. So this is called the trade winds. Winds that are coming from the upper atmosphere to the Earth's surface, these are called the trade winds. Or you can say that winds that are coming from 60 degree to the equator, 0 degree, those are called what, trade winds. Simple. The one more important concept is here that winds we usually give the name on the basis of the direction in which they are coming. Here, if you can see that the winds that are coming from 30 to 0, usually they seems to be come from the northeast direction, northeast winds, or we can call it northeast winds. Similarly, from 30 south, 30 degrees south to 0. This seems to be appear from the southeast direction. This is east, this is south, so this is this one. This is come seems to be appear from the this direction, so southeast trade winds. So usually remember this, winds we usually give the name on the basis of in which direction they are coming. So winds that are coming from 30 to 0 north, they are called northeast trade winds, or you can say that these are trade winds, or the winds that are coming from 30 degrees south to 0, these are called southeast trade winds, or simply trade winds. Rest is given is here, you can go through that. Similarly, we have the westerlies. What are westerlies? Winds that move from 30 degree to the 60 degree. Winds, there is a much more broader concern involved, but I will not go there. How these winds, simply winds are generated because of the high pressure to the low low pressure belts. Things are given here, and the equator is, this is low pressure. After there will be a 30 degree high pressure. We have 60-degree low pressure. We have 90-degree. We have high pressure. Simple way. The winds that are coming at 30 degree, we have high pressure here. 30, we have high. So winds move from 30 to 60, because 60 we have low pressure. From winds move from high pressure to the low pressure. The winds that move from in the northern hemisphere 30 to 60-degree north, these are called westerlies, or we can call the south westerlies, southeast, no, southeast, or these are seems to be coming from the western direction, north, south, east, and west. Westerlies, or these winds that blow from subtropical high to the temperate low, these are called westerlies. Similarly, in the southern hemisphere, winds that blow from 30 degree south to the 60-degree north, these are called north northwesterlies, because they are seems to be coming from the north direction. This, so you can see that they seems to be coming from the north direction. Coriolis force is more at the equator. That's which results that at the equator, this the bending of these trade winds will be more compared if you go in higher altitudes. These seems to become coming from the north, because at the poles we have the less Coriolis force. So in this it is showing that these winds are coming from like northwest direction, but at the higher altitudes they seems to become, because at the higher altitude there is less Coriolis force, which seems to be these winds are called, that's what called the northwesterlies. Similarly, we have the temperate low to the polar high. These are called the polar easterlies. Okay, this is about the trade winds. Here is given. You can go through that. Okay, bye.